Okay, make sure you have a pen and paper ready to make notes of things you think you'll need to remember. Listen again. Remember, a video can be paused and rewound if need be. Be prepared to pause for any activities or to do a quick bit of reading, and make sure you do all the activities. That will help you learn the most. Okay, we have 2 starter questions here today. Give these a go. Give yourself no more than 4 minutes to have a go at this. Okay, the answers for these are here on screen. 0.2 for yellow. If you do 0.2 times the 40 counters, you'll get that there are 8 blue counters. On the second one, as you can see, because it wants 2 socks the same colour, I've gone for black and black and white and white. And there is a total of 34 out of 64. Remember, there's no need to simplify your fraction for that. Okay, today we'll be looking at the product rule for counting. So, here's our first question. An ice cream kiosk, you can choose a flavour of ice cream and 1 topping. How many different ice creams could you order? Well, simple listing, you could order a vanilla with flake, a vanilla with sprinkles, a chocolate ice cream with flake, and a chocolate with sprinkles. So 4 different options. Here, more options for flavours and toppings. So now there are 9 different choices. Now, as you can see, these lists are already getting big. So what we tend to do, rather than use full words, we will use a single letter to represent each one. So, for example, V for vanilla and F for flake. Okay, so I want you to have a go very quickly at writing out all the different options that Sam could have from here, choosing 1 flavour of ice cream with 1 topping. So pause it, have a quick go, see if you get them all. Okay, here is my list. Vanilla flake, vanilla sprinkles, vanilla nuts, vanilla marshmallows. Here's all the chocolate options, and here's all the banana options. And you'll notice I've done all the vanillas in one list, all the chocolates in another, all the bananas in another. That just makes it a little easier to make sure that I don't miss any. Now, see at the bottom, what is the connection between the number of options and the total choices? Well, let's have a quick summary of those. We had 2 flavours and 2 toppings, and we had 4 different options altogether. When we have 3 flavours and 3 toppings, we have 9 options. 3 flavours and 4 toppings give us 12 options. So my question to you is, if I have 10 flavours and 5 toppings, I'd have 50 options. How am I working that out without listing them? Hopefully, you'll have noticed that all I'm doing is multiplying them together. So for the first one, 2 times 2 was 4, 3 times 3 was 9, 3 times 4 was 12, 10 times 5 was 50. Much easier to do it that way than to list them all out. If you don't need to know every option, you just want to know how many choices, much faster to do that. So, there are 3 questions on screen. I'd like you to have a go at each of them. The first one wants you to list the options, but the other 2 only want to know how many different combinations you have. Pause it now, have a go, and then unpause for the answers. The answers for these then, the first one, total of 9 different choices, and I've listed them all there. The second one, I had 3, then another 3. I multiplied all of them together, 27. And the final one, I had 4 starters, 6 mains, 5 desserts, 120 options altogether. Okay. Now what you've been doing so far is something called the product rule. We call it the product rule because we are using the product, the multiplying of different options to get our answer. And it can be used for a lot of different scenarios. For example, your mobile phone probably has a code to unlock it. So if that code has 4 digits, and each digit is 0 to 9, There are 10,000 different possible combinations. Now you could sit there and list them all, but that would take a very long time. Instead, if there's 4 digits and the first one could be 0 to 9, then there are 10 different numbers that first digit could be. And there are 10 different numbers the second one could be, 10 that the third one could be, and 10 that the fourth could be. So 10 times 10 times 10 times 10, 10,000 different PIN codes. Have a think now. What if it was a 5-digit code? How many combinations would there be then? Quick calculation. 1, 2, 3, 4, 5 tens all multiplied together, 100,000 different codes. So adding a single extra digit has given us 90,000 extra possible combinations, making it a much more secure code. So I want you to have a quick look at this one. Just pause it and have a quick go. How many different possibilities could there be for a 3-digit code? Okay, so the answer for this, the first digit would be 10 options again, and 10 options again. 10 times 10 times 10, 1,000. How is this different? The first number is a square number, so the other two are random, but the first number is a square number. Your square numbers are 1, 4, and 9. So try and work out now how many different codes there could be if it's 3 digits and the first is a square. Okay, so this one, my first digit, there were 3 options instead of 10, so I'd have 3 times 10 times 10, 300. Okay, here's a slightly different question. Have a think about this one. The middle number is less than 2, and the last number is more than 5. It's not said anything about the first number, so that's still any number 0 to 9. So try and work out how many different possibilities there are for this one. Unpause it and you'll get the answer. Okay, now this one might have caught you out because the numbers less than 2 are 1 and 0. So there's 2 options for that. The last number being more than 5 would be 6, 7, 8, or 9. 4 options. Therefore, the first digit could be any of the 10. The second digit could be 2 different numbers, 1 or 0. And the third digit has 4 different options. So if you multiply 10 by 2 by 4, you get 80. I'd like you now to have a go at these. I've got a 4-digit code on my PIN number for my bank card, and it uses the numbers 0 to 9. So I want you to answer these 4 different ones to see what you think they're going to be. Pause it and then unpause for the answers. So the answers for this, the first one is 10,000. The second one is 5,000 because the last number could only be 2, 4, 6, 8 or 0. So there's only 5 options for the last one. On this one, because the first number we know is a 4, there's only 1 option, and that's 4, so that's it. Numbers greater than 7 is 8 or 9, 2 options, and the others are 10s, 200. The final one is 5,040. We'll talk about why in a second. So, that very last question, we had a situation where the options started to decrease. Okay, so as you use up a number, you had less and less choices. Now, I'd like you to look at this, and then this will hopefully explain what happened there. Imagine you've got 5 numbered cards as shown. So I've got 5 cards, all with a different number on, and I'm going to hand those out to 5 people. Well, if I do that, each time I do, I'm going to have 1 less card in my hand ready to give to people. Okay, so my first time I hand one out, I've got 5 cards to choose from. But when I go to my second person, I'm only going to have 4 cards left. I go to my third person, I'm only going to have 3 cards left. Then I'll only have 2 cards left. And when I go to my final person, I've got this 1 card that I've got to hand over. It's the only choice I have. So for this scenario, there are 120 different ways I could hand those cards out. But as I went, I used up the cards, my options decreased, and that's why the numbers go down. And that's what happened on this last question here. If all the numbers are different, I had 10 choices to begin with, but on my second number, I've used one of them up, which means I've only got 9 left. And then by the time I get to the third one, I've used 2 digits up, so I've only got 8 left. And then my last number, I've only got 7 to choose from. So I'd like you now to come up with how many different ways you can arrange these 3 cards. So pause it, and if you need to, you could write out the different options, but there's a much faster way I'm hoping you'll use. So the answer for this would be 6, because I'd have 3 different options for the first card. That would leave me with 2 choices for my next one, and only 1 choice for the last. And just, if you did list it on the bottom right corner here, I've got all of the different options. So 6 total possibilities. Okay, this one I'd like you to do, and I definitely don't want you to list all these out. How many different ways can you arrange these 6 cards? Okay, so for this one, you'd have 6 possible for the first, then 5, then 4, then 3, 2, and 1. If you multiply all those together, you'll have 720 different ways, and you can probably see why I said not to try and list them all out. It would take a very long time. And finally, I'd like you to look at this one. So I've got the codes, a keypad that has 13 different buttons on it, 13 characters, and I've got a 4-digit code again. The code has no repeated characters. How many different codes could there possibly be? So just have a quick work it out now. You will need a calculator, and then unpause it for the answer. Okay, so you'd have 13 possible ones for the first one, then 12, then 11, then 10. Multiply them together, 17,160 possible different combinations. Just think how much more secure that's been made by just adding 3 extra buttons. So, on screen now, you have a worksheet that goes from A to M. Plus there's a little one here that doesn't have a letter on it. Work through those, whichever ones you'd like to. Read them very carefully though. For example, when it says how many odd numbers greater than 500,000, you've got to think very carefully about what that means, okay? For the first few, I have given you clues on how to interpret the question. But be very, very careful about how this will work. Okay, so pause it, and you can unpause it and it'll give you the answers. So the answers for all of these are on screen now. I apologise, I know they're quite cramped, so just you might want to pause it while you check your work. Okay, once you've done that, please make sure you do submit your work to your teacher. Well done for today.